Hello and welcome again to the ZGuy programming channel. Python edition. Today's topic, syntax. Syntax refers to the spelling and use of special keywords. Computers are only able to understand what you give it to process if it is in the exact form it expects. Computers are pretty smart, but they don't make assumptions about what it thinks you meant. It will do exactly what you tell it. So you could think of syntax as the grammar rules that any spoken language has. The first area of syntax that we'll discuss relates to variables. Variable names can be made up of letters A to Z, uppercase and lowercase, numbers 0 to 9, and underscores. Variables cannot start with a number. You will get an error. Variables are case sensitive, so this means that A lowercase equals 10 is different than A equals 15. They are not using the same storage location in memory. They are separate. So to demonstrate that, we will print lowercase a and uppercase a. Let's call this Python application this time syntax.py. Save that. Go to your folder that has the program. So let's run that program. And you'll notice that we got 10 and 15, lowercase a, uppercase a, different variables, different storage locations, different values. Now Python has many keywords as part of its programming language that may not be used as variables. Here's a list of some of the most common. You may want to pause the video and write these down. As you'll see in my particular editor, keywords are highlighted in blue, so it's an easy reminder as you're typing your program. If you were to type a keyword that you thought you were going to use as a variable, it would come up in bold blue to indicate that's a keyword. You can't use it as a variable. Not all editors do this, so just be mindful that you'll run into problems if you ever try to use one of these keywords as a variable in your program. The next element of Python syntax that we're going to discuss is indentation. Most programming languages don't have such strict indentation requirements that Python does. Now we're going to talk about some statements here, if and while, that we aren't necessarily going to get into exactly how they work, but they're going to we're going to use them to introduce the concept of indentation. So in this example we have if a greater than 15, b equals 4, print b, else b equals 55, print b. Think of these two lines of code as a block of code that relate to this if statement here. If a is greater than 15, then do these two things. If it's not greater than 15, come down to this else and do these two. And the way it knows what lines of code relate to this if statement is through indentation. So if we run this program, we get an error code. Now, why do we have an error code? It looked like it was pretty straightforward code there, but what we get as a message says a is not defined. Now, this is part of the syntax of programming. You can't use a variable, you can't evaluate a variable if we don't know what it is. It's never been set equal to something. So let's go back. Let's set a equal 10. Save it, run it again, and we get 55. So again, we're not really talking too much about, well, how the if statement works, but because A is not greater than 15, we drop down to the else statement. We assign B 55 and we print B. All right, so let's look at this again with another example. In this case, we're going to use a while statement. While A is less than 10, perform this block of code. Okay, we have an assignment, a print, another assignment statement, a print, and print some dashes. Let's look at what this looks like. Okay, same thing. We get another error. B is not defined yet. We don't know what that is. So we're going to set B equal to 2 for this example. This is the process you'll run into when you're writing code. You'll write something, and the Python interpreter, as you execute your code, will let you know, hey, this program's not all complete. Something's missing here, and it will flag that with error messages when you attempt to run it. All right, so what we get is a loop that prints A and C, and A is just incremented by 1, and then C is a mathematical calculation, and you get, you know, 2 numbers in a line, 2 numbers in a line. All right, by making a very minor change visually to our program, we can drastically change how the program works. So what happens if we just take these 2 lines and change the indentation? Bring those 2 lines to the beginning and get rid of those previous spaces. What happens? Well, now we get our numbers. Our A statement prints 1 through 10, and then we print C and our dashes at the very end. So now our block has changed from 5 lines of code to just 3 lines of code. And it runs through these 10 times, drops out of our loop, and executes the next 2 statements. So again, very important. How you line up your statements has a drastic impact on how your code is executed. Okay, on this next block of code here, I want to bring out a couple of examples. You'll notice this has changed a little bit from the while statement we had in our previous example. In a very minor way, but what we had before was a space on either side of the less than sign. So it's not required that you have a space or no space. I prefer that we keep the space, again, for readability. I want to be able to go back to this code or have someone else look at this code, and to me, visually, it's easier to read it if you put the spaces around it. Separate the variable A from the evaluation of the number 10. It just highlights to me more easily that you're looking at a less than evaluation when you create that separation. Not a requirement syntactically. This is just a visual thing that I like to do with my code. All right, so at first glance, this is the same kind of code we just looked at a little bit ago. We print a couple of variables, we do a little calculation, and I just make a comment here, you know, don't be afraid to add blank lines within your code to, again, enhance readability. You might use a blank line to separate a section of code that, you know, quite often you'll have, you know, 10 lines of code that are related to each other, performing some calculation or manipulation of information. and then you'll have another 10 lines of code that are doing something unrelated to the first 10, and I like to group those together by putting blank lines between them, again, to enhance readability. It's not a syntax requirement, it's to enhance readability of your code. Alright, so let's run this and let's see what we get. Alright, so we get an error, a equals a plus 1, indentation error, unexpected indent. So let's go look at that again. Where's a plus 1? Here we go. And so you were typing along and you're hitting your space bar trying to get your columns all lined up, and you accidentally hit one too many spaces and moved your a equals a plus 1 too far to the right. Python looks at that and says, I don't know what you meant. You had these other lined up statements, and this one, it's not in the right place, and it knows that, and so it's going to flag it and give you an error. You simply need to bring it back in line with your other ones. You can rerun that program, and then it runs successfully, prints your numbers and your dashed line at the end. This next syntax related item that we're going to look at talks about putting multiple statements on the same line. So as you can see here, on one line of code we have an assignment statement for A, an assignment statement for B. We have a conversion of A from an integer to a string, and it's being concatenated with some text, and then we're printing A and B and C, and we're doing many different things all on one line of code. Again, syntactically, Python allows you to program this way. Personally, I find that, again, more difficult to read when you're programming, you're trying to debug a program, and you've got to look at that line of code, and if you just looked at it, it could look very confusing, and you're not able to quickly pick out the piece of code that you need to spend some more time on, or maybe you're trying to debug, and with all those statements put together on one line, it makes it more difficult to pick out the one piece that might be causing you problems. So I recommend, from a readability standpoint, again, I'm really big on readability, that you put these all on their same line, or that you put all of them on their own line, and you don't need these semicolons if you put them all on their own line. You only need that semicolon if you're going to put a bunch of commands together on the same line. So that's a command delimiter when they're put together on the same line. Otherwise, you don't need them. Alright, so every statement, as a recap here, every statement in Python has its own syntax. We've seen in this video the if and the while statements. Each statement will have its own special requirements that you will have to follow when you use it. Variables have to be placed in certain locations. Special delimiters like the colon or semicolon or parentheses also have certain locations that they need to be in. The online Python manual is a great resource. It will explain to you how a command works. It will show you where the parameters are supposed to be, what the delimiters are between, whether it's commas, etc. And that resource can be found at the following location. Take a look at it. It's a great way to become more and more familiar with the language. And most of the commands give you examples on how to use that command and what the expected results would be. So again, I hope you had a good introduction to syntax, and we will continue to delve more and more into the Python language in future videos. So stick with us and enjoy this Python learning experience.